Good morning, good evening, and good afternoon, whichever is currently applicable in your time zone. I am Max, and this time I will be talking to you about Desynced and its logic system. One common misconception is that logic in Desynced is something you need to start using once you learn it. In fact, nothing could be further from the truth. You, as a player of Desynced, have used the logic components already. So, let us grab first Scout, turn off its work, and let's talk about the details. First of all, I would like to show you the 4 main registers. For the record, in this video I will be using parameters and registers interchangeably, as functionally they do not differ that much. I will, however, talk about both read-only and read and write registers, but let's focus on 4 main registers. These 4 registers are as follows: signal register, visual register, store register, and go-to register. Well, if we hover over go-to, you may see that, wait, it is right mouse button. It means that whenever you command a unit to move, you are in fact setting up the go-to register. You want to pick something up? It is also go-to register. You can in fact drag and drop go-to register, and it will be basically the same thing. Second register that I would like to talk about is a store register. For that, let me quickly create additional storage unit to make sure I indeed am able to store something in a way that is clear. Whenever you set store register, either through drag and dropping, I recommend using drag and drop to make it clear what you're doing initially. Later on, you can replace it with Ctrl right mouse button. Whenever you set up store register, unit, that is doing the storage, will move any and all cargo to the unit designed as a store register. For example, if I were to set store register to HQ, you will see that our unit will drop it into the HQ. This was mentioned during the tutorial. However, I would like to point out that store register is not a high priority register. It means that when unit doesn't have anything better to do, it will indeed drop it off immediately. When it does have something better to do, such as mining, it will ignore the store register initially and do the rest. For example, here it will go mine first. This can be used later on. Second thing I would like you to note is that store register allows you for some rudimentary automation. And it is both read and write register. That means that if you want to follow a unit that you set as a storage, you can drag store register to the go-to register. What it will do? Let me quickly show you. Let's turn off the miner for now, and let's set store register as a scout. This way, our miner will dump everything to the scout and follow it. As both go-to and store commands are read and write, we can do it the other way around. This option will be useful when we talk about robotics facility. Third register is a visual register. You were setting it up during the tutorial as well. However, what wasn't said is that there are two, or rather three, methods of showing the icons. First is the one shown in the tutorial. Simply, you set it up. It doesn't have to be the same as what you're doing. It is recommended, however, to do so. The two primary ways are value. For example, this is a value of 0 or value of 20, or the infinite mode. The infinite mode will basically show you how many items from that inventory are of the type that you have a visual register of. So as you can see, it has 4 units in cargo, and it says so, it shows so, despite having infinite icon here. This allows us to quite easily see, for example, how many items we have in which factory ready to pick up. So we can see that this factory has 1 unit of bars ready to pick up and use later on, and we can see that this factory has a full stock of plates. This can be useful to see which elements we are missing or which elements we are waiting for. Additional thing that I have to keep you in mind, that I want you to keep in mind, is that registers are not only in the form of 4 main registers, but also components. As we can see, here we have a register, also read and write register, on a laser mining tool. This means that if we set visual register, for example, to infinite amount of crystal, we can, in fact, link it. If we change the visual register, our miner will also change the target of mining. There's one more thing that I want you to remember. Whenever you order the unit to move, it will clean up registers in, for example, mining tools. How can we fix that? How can we simply right-click and not have to bother with resetting the mining laser tool? Well, as I've shown you. Let's grab visual, link it, and now as we move, our register will stay as intended. And finally, we have signal. Signal basically makes that register value available for other units. Let's quickly grab a signal reader. Let's link our input register to the unit we want to see. And our output register will be, in fact, nothing. Why? Because our signal is still empty. If we are to set, for example, our signal register to the crystal, we can see that our received signal is a crystal. This is the way that you can use to transfer information between two objects, for example, two buildings. Finally, there's one more thing. Most components have registers, even though they may not feel like that. For example, as you can see, the assembler also has registers, input and output register. Well, input is a widely overstated term, as this register can be read or written as well. Okay, but what's the point of that? Well, whenever you are ordering an assembler or a fabricator to build something, you are setting the data register. How to use it? Well, relatively simply. You select what you want, and you select how many of these you want. I will quickly turn off the power grid just to highlight you a few things. I'm afraid I will have to make it again. This time I will use robotics facility, as frankly it has components that we can't produce yet automatically here. So let's get an energized plate as an example. Now, the input register is what we want to produce. The output is what we're missing. What we can do is we can drag what we are missing to the input or read and write register of an assembler. This way, whenever our robotics assembler is producing whatever and its missing component, it will ask our assembler to produce that component. For example, if we were to build a worker, it will ask to make a single circuit board. We can also expand it. As I've said, we can transfer data outside of our simple building all the way out to other units by dragging it to signal register. This way, if we get different building, we can drag and drop or link command center, and our signal reader will say that our command center requires right now circuit boards. Notably, we can use multiple elements and drag them at the same time. This way, if one of those factories doesn't have enough materials to produce what it needs, it can request them outside. Let us use in something more practical. However, before we do that, I will quickly talk about portable radar. Portable radar is a device that scans its vicinity, specifically that area around the unit, for an object fitting the filters. For example, if I were to choose a crystal chunk, it will find the nearest crystal chunk, whether it is mineable or not. If we want to look for dropped items alone, then we can look for dropped items. This way, our portable radar will be looking for nearest dropped crystal chunk, which would be this one. Let us use it. Let me quickly grab our example scout and let us set up simple janitor. First of all, we will be dropping everything to the storage block. So let's drag store here. Second, we need a portable radar. Let's grab it. Okay. Now, we want to search every dropped item. And now we have to pick it up. As you remember, we can pick up items by right-clicking on it, but right-clicking is the same thing as setting Go To register. So let us link the output register to the Go To register. And we see that our bot will now look in the area around it, find dropped items all around it, and once it is done, it will drop them to our storage. However, as you can see, it's going a bit too far outside of the base. So let us add additional filter. If we are to act as janitors near our base, I recommend using in power grid. This way, it will look only for objects that are within the power grid. That way it won't be getting attacked by NPCs. So now every item within the power grid will be dropped here. Dropped item within the power grid will be dropped here. Additional function of a signal is something that we can use during building. Let us change our filters a bit. Now we will be using construction sites nearby. And let's clean this up. As you can see, we know the construction site. Let us quickly grab an a signal scanner. And as I've said, signal scanners can be linked. When linked to a construction site, our signal scanner will show what is currently needed by that construction site. If we link it, we will now see that our radar and our signal reader will show that our nearest construction site needs solar cells. It's not really that useful on a mob unit without M-sized slot, but let us copy that setup onto our command center, because why not? Construction, and I will limit it to our own only. So our command center will now be looking in this area for any construction site, find the closest, then read what this construction site needs, and then order its assembler to build just that. Let me quickly turn on the logistics again. As you can see, we have no factory that produces solar cells by itself. However, as you can see here, our solar cell is still being produced by a command center. This is a bit more complex system, but should work nonetheless. And finally, there's one more function that you may find useful later on. It's a single signal reader can read whatever is needed for explorable. For example, if we were to go to this explorable, there would be no material needed to open it. If we were to go to this explorable, however, there will be one circuit board needed to open it. Let's verify it. Let's grab one circuit board, because we trust our signal readers. Let's go to the nearer one. As you can see, we don't need any materials here. Let's go further. And this one should need plate, board, and indeed it requires a circuit board. So we can transfer it. We can use this function later in the behavior. These would be the basics of using registers. There is a final element that I would like you to note, however. When you are using robotics assembler, you can set up rally point. What it does is it will set up rally point of produced item, for example, this miner, to the object it's linked. It will basically set up go to register to the object of interest, or to the rally point, whether it is location or a unit. I will be talking to you how to use it shortly in the next video.